our warm-up, we are solving for x, and when you solve for x, I'm asking you what is x going to be to make this true. So 2 to what power is 16? Or 2 times itself, how many 2's multiplied to make 16? What do you think? So let's go with 8. 2 times 2 times 2 times 2 times 2 times 2 times 2. Okay, it's huge. That's a huge number. Now, if you're adding 8, 2 plus 2 plus 2, 8 times that, that'll be 16. But what did you say over here? 4? Let's try it. 2 times 2 is 4. 4 times 2 is 8. 8 times 2, 16. It works. So 2 to the 4 power, right? 2 times 2 times 2 times 2 equals 16. And all that means is 2 to the 4th power. So x equals 4. Do you see how that works? Now that's kind of a abstract way of kind of puzzle solving it, but I'm going to show you today on the notes how to solve exponential equations like our objective today is. Okay, let's do this. What's up? Yeah, it's right here. There's a warm. So we're on 9.2. Now, the original notes had a whole front and a whole back. Do you see how the back is blank? Yeah. Okay, so I tried to make this shorter because I know when we have long notes, we tend to like. So what I want us to do is for like 5 to 10 minutes, if we can just not have headphones in our ears, please. All right. Hardly headphones in their ears. Over here? Okay. It's all good. It's not good. I see. Where's the front of this one? It's in its pocket. In its pocket? Yeah. That's weird. You take it out of your ears? Appreciate you. All right. I know you got it. So take it out. All right. Here we go. Yeah. Those are your dummy ones. You got 2.
Where?
Oh, okay. You got them implanted behind Bluetooth, you know. All right, everybody. So number 2, an exponential equation is an equation where the variable is in the exponent. Everyone see this on your notes sheet. Okay, we knew that, hopefully, but this is important. Look right here. The property of equality for exponential function says if b to the x equals b to the y, that means then x equals y. Now, what's the difference between this and this? What's the one difference? Look right here. What is here that is not here? The b. Okay, do y'all see how the b has disappeared from here to here? Okay. So all I'm saying is if the bottom, by the way, it's called a base. If the base is the same, you can basically just like get rid of that base and set those exponents equal to each other. They kind of come down and they're equal. Okay. Now, when we're solving these, here's your steps. This is already on your notes. Step 1, make sure both sides are powers of the same base. Step 2, set the exponents equal to each other. And then 3, solve. Not going to be that hard. Here we go. Example 1. Step 1, is the base the same here and here? Yes. Easy problem. Right? So, if the base is the same, here's what you do. Cross out the base. I don't need no base in my face. All right? So the 6 is gone. What's left is the exponent. So x plus 12 comes down, 5x comes down. Those are equal. Okay? Where's the other one? Take it out. Now, you see how it works? Same base, bring them down. Where is it? Put it on this so I can see it. No, put it over here where I can see it. Thank you. Thank you. Now, can you solve this equation? Let's remember, what do we do when x is on both sides? Do I combine them or do I get rid of one? Not the 12. So, sorry. Shoot. Oh, pause. The rule is to get rid of the smaller x, right? So you can't combine them because they're on different sides. Which x is smaller? Just a 1x, right? How do you get rid of a positive 1x? Subtract, okay? So subtract 1x on both sides. 5x minus 1x is what? 4x is on the right. Bring down 12. What would I do next to get rid of that 4 in front of x? That's being multiplied, so the opposite is to divide. Divide each side by 4, and what do I get? What do I get? 12 divided by 4. Is it 4? Is it 14? What's 12 divided by 4? Thank you so much. 3 is the answer. 3 equals x. Was that easy-ish? Kind of mid-tier, like C tier, right? All right. Next one, example 2. Ready? Does anyone still need this? Apparently not. Example 2. Does it have the same base? Does it have the same base? All right. So 5 and 5. So guess what we do? Cross out that base. Get that base out of my face. And I have 7x equals 4x minus 6. All right, what do I do when x is on both sides? Get rid of the, you can actually get rid of either one. I like to get rid of the smaller x. Which is smaller? 4x. It's positive, so yes, we are subtracting 4x. 7x minus 4x gives me what, student? That is so wrong. 7 minus 4 is 3x. 3x equals negative 6. And then, yeah, to get rid of that 3, we divide by 3, and we get, what do we get? Why don't you just answer? What is it? Negative 6 divided by 3. Negative 6 divided by 3 is a negative 2. Right? Don't forget about those negatives, right? Negative 1. Right? All right. Now, wait. We got some more difficult ones. So I need you over here. Example 3 and 4. Ready? Now, what is different about example 3? The base does not match, but there's a way to get them matching, okay? Now, do you see in the middle of your page this thing right here? This is your friend when you're doing this. What we want to do is turn this 27 and turn this 9 into the same base. So look over here. Does everyone see 27 right there? Right? What is 27 really equivalent to? 3 to the third power. Seen this? Questions? So 27 is 3 to the third power, right? What about 9? 3 to the second power. Do they have the same base? Yes. They do. So your base might be able to be broken down into a smaller base that's the same. Okay, so again, when you have bases that don't match, take a peek on your little cheat chart here, and it'd be nice to memorize it, but I'll let you use your notes, of course. Now look, here's what we're doing. 27 is 3 to the third power, so kind of replace that with a parentheses 3 to the third power. And then 9 is 3 squared, so replace that with a parentheses 3 squared. We will. But let's answer the question. Are the bases the same? Now, yes, but the exponents are kind of weird. What do you think we're going to do with this 3 and this x minus 1? No. Okay, we are going to multiply. So here's the deal. This is something you might have learned before. If you have an exponent to another exponent, you multiply those together. So when you multiply 3 times x minus 1, that's going to be what we call distribution. Y'all know about that? Yeah. Look at this. See those little arrows? Hey, see those little arrows? You're distributing, which means you're multiplying, like we said over here. So that what it is, okay? Your new little exponent on the inside has to multiply to the old exponent. New exponent in the middle, on the inside, multiplies to the outside. So what's the math here? What's 3 times x? 3x. 3x. What's 3 times negative 1? Negative 3. Negative or minus 3. And on the other side, 2 times 2x? 2 times 2x? That thing. 4x, right? This thing's going to break one day. Don't let it. Just try to stop smacking it. I had no reason to smack it every third period, you know? All right, so now do you, no, not people. Okay, now, are these bases the same? Say it. No, say it the right way. Yes. Now, scratch out those bases, set them equal. 3x minus 3 equals 4x. What should we do next when x is on both sides? Subtract the lesser x. Get rid of the smaller x. How do I get rid of this positive 3x? Subtract it. Okay, so I subtract 3x on both sides. What is 4x minus 3x? 1x, which is just x, right? You bring down negative 3. Please don't forget the negative sign when you bring down that 3. Please. Now, even though that was like an extra step, can't you do that? So yes. Yeah, just switch a root. That's called the commutative property, reflexive property, symmetric property, something like that. All right, ready for example 4, student? All right, yeah, generic students, NPC students that I cannot say your names. All right, so 16 and 8, do they have a common base? Look in your little cheat chart here. Yeah, 16 has a base of what? Well, kind of. Also over here. Well, yeah, okay. It could. But 4 doesn't go into 8. You know what I'm saying? No, 4 does not have an exponent that goes into 8. 4 squared is 16. Right? So again, forget the 4s. Let's go down to these 2s. 16 is what? 2 to the 4th power. And then 8 is 2 to the 3rd power. They need to both have the same base or you can't do this stuff, right? All right. So here's how we write it. 16 is really 2 to the 4th. 8 is really 2 to the 3rd. Right? R-I-G-H-T, W-R-I-T-E. Right? Right? Is that it? I think I did this right. Are you done? About to be. All right. Now, what do we do with these exponents again? With the 4 and the x? Multiply them, distribute. What about 3 and 2x and 3 and negative 10? You got to distribute. You got to multiply them. Does everyone see these little red lines? Are the distribution, the multiplying? What's up? What's up? Sure? All right, now 4 times x is what? 4 times x is what? 3 times 2x is what? No, 3 times 2x. 6x. 3 times negative 10. Negative 30. All right, so we get 4x on the left side, 6x minus 30 on the right side for our exponents. And again, cross out the base, the disgrace that you must erase out of my face. No. And then you get 4x equals 6x minus 30. Now, there's 2 ways to do this. Usually I say get rid of the smaller x. So I'll do it off to the side here. If I was going to solve this the Mr. G way, which is the G way, you get rid of the smaller x. But what happens when 4x is minus 4x? What's left over? No, what's 4x minus 4x? 0. And now on this side, 6x minus 4x is 2x. And I know people get weirded out by zeros, but you can still solve that, right? What do I do first to get rid of that? Minus 30. Loader. Plus 30. 0 plus 30 is 30. And then you get rid of the 2 by dividing by 2. You get 15. But the way they do it on the notes is they get rid of the 6x and then have to divide by negative 2. Whoop. But you get the same answer either way you do it, okay? So you can do it from here this way, or you can stop working, which is super cool. Or you can do it this way. So, again, we could have done like 4 more examples, but I spared you so that way, because I think you get it. Does everyone kind of get it? Or you can use these notes to kind of guide you. I'm going to give you 9.2. The one thing that's weird about some of these problems is if you get the same x on both sides, then there's no solution. Like if the x's cancel out altogether, no solution. So if you get to a weird one and you're not sure, you can ask me, but it might be no solution. I'll leave this on the board, and I'm going to pass out 9.2, and we'll get started on that. I am grading 9.0 and 9.1. Make sure those are turned in, and some of y'all still need to do more test corrections. We'll see who. All right.